In this video, we'll write the balanced net ionic equation for AgNO3 plus FeCl3. This is silver nitrate plus iron 3 chloride. First thing we need to do is balance the molecular equation. I can see there are 3 nitrate ions here and only 1 here. So I'm just going to put a 3 in front of the AgNO3. Now I have 3 silver atoms, so I'll put a 3 over here. Those are balanced, but now I have 3 chlorines. Well, that's good because I have 3 here, and then I have an iron here, an iron here. This is the balanced molecular equation. Now I can write the states for each substance. If you know your solubility rules, silver nitrate. Nitrates are very soluble, right? AQ. That means this is going to dissolve. It's going to split apart into its ions in water, dissociate. Chlorides, very soluble, AQ. Another nitrate, AQ. But silver chloride, let's take a look. Whenever you see silver, that's one you should be a little bit cautious with. So here's a chart of solubility, and we can find silver right here and chloride right here. You can see most of the chlorides are soluble, but we go across and down. I for silver chloride. That means it's insoluble. Good one to memorize. So silver chloride is insoluble. When we have this reaction take place and the silver chloride is formed, it'll be a solid. It'll be a precipitate. It'll fall to the bottom of the test tube. So we're going to write solid for our silver chloride. Now we can split the strong electrolytes into their ions for the complete ionic equation. So silver nitrate, that is aqueous, so we'll have 3 silver ions. Silver is always 1 plus, and then the whole nitrate, that's always 1 minus. Good to remember. 3 Ag plus, and I won't write aqueous each time. We'll do that at the end, plus 3 nitrate ions. And then for the iron 3 chloride, we can't really tell the charge on iron just by looking at it. We need to look at what it's bonded to. Chlorine atoms, they'll form ions with a negative charge. So we have 3 negative charges. This has to be 3 plus. That's why I was calling it iron 3. So we have 1 iron 3 ion plus 3 chloride ions. And those are the reactants. In the products, here again we have nitrate, which is negative. We have 3 of them. It's going to be 3 plus. So we'll have Fe 3 plus, and then we'll have 3 nitrate ions. And then for AgCl, because it's a solid, we don't split this apart. We're just going to write 3 AgCl. These are the products. Once we've done this, we can then cross out spectator ions. They're on both sides of our complete ionic equation. I can see in the reactants there are 3 nitrate ions here and 3 here. I can just cross those out. They haven't changed. We're not interested in those. There's also an iron 3 ion here, and then in the products. Cross it out. What's left is the net ionic equation. I'll clean this up and write the states in, and we'll have our net ionic equation for AgNO3 plus FeCl3. So this is the net ionic equation for silver nitrate plus iron 3 chloride. You'll notice that we have the same coefficient in front. It's 3, 3, 3. We can reduce that to 1, 1, 1. We don't even write the ones. And this is a more compact net ionic equation. You'll also note that we have a positive and a negative, and those balance out. We get a neutral compound. So charge is conserved, and we have silver, silver, chlorine, chlorine, and we also have mass conserved. So this is our net ionic equation, and this is Dr. B. Thanks for watching.